Hi guys, this is Unit 9, Day 4, Dividing. So, in the past when we did multiplying, which was our simplifying, we were allowed to say that if we had two things underneath a radical where we could break something down, we were allowed to break those up so that they had their own separate radicals. So we could say that if we had a times b underneath the same radical, we could break it up to be radical a times radical b, and they would both get their own. So when we're doing multiplication, we have a similar property when we're doing division. If you have one big radical covering a fraction, so the whole fraction is underneath the radical, we can separate this so that the radical goes to the top and the radical goes to the bottom. Now, we can go both ways with this in order to, whatever way is going to make it easier for us to use. So we can take a big radical and break it into two little radicals by going this way. Or we can take two little radicals and make them into one big radical going this way. So this property goes both ways. Same with this one. This one we could have broken things up and put them back together. Unfortunately, when we are doing division, there is a little thing that radicals cannot be in the denominator. So as we know, the denominator is the bottom of our fraction, and we're not allowed to leave radicals there. So what we're going to learn in this lesson is how to clear them, so how to get rid of the radicals in the denominator. So that's what we're going to be looking at today. And just a reminder, if we have something like radical b divided by radical b, that is equal to 1, because anything divided by exactly itself is equal to 1. So it doesn't matter what's in this radical, as long as it's the same as what's in this radical, it's equal to 1. And just a reminder that multiplying things by 1 does not change the way that the value of the problem. It may change the way the problem looks, but it will not change the value of the problem. So let's do some examples together. And sorry, I don't know if you can hear that, but my cat is running around. So example 1 is radical 3 divided by radical 12. So radical 3 divided by radical 12. So they are separate radicals. We can make them into one big radical if we want to, or we can rationalize the denominator by multiplying top and bottom by whatever radical is in the bottom, because we want to get rid of that radical. And just like we said here, any radical over itself is equal to 1. So multiplying by radical 12 over radical 12 is like multiplying by 1, so that's not going to change the value of the problem. It's just going to change the way this problem looks. So 3 times 12 are both underneath the radicals. That gives us 36. And 12 times 12, also both underneath the radicals, gives us 144. If we take a second to revisit our lists of perfect squares, I'll just do these off to the side over here. Remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and I know I'm a little bit off screen. Let me move down there for you. 169, 196, and 225. So those are the perfect squares that we used during our last unit, and this is 1 through 15. And remember, to create this list of perfect squares, all you're doing is 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. And these are our perfect squares. And so this list could go on forever if you wanted to keep creating perfect squares, but for the purpose of what we're doing today, we probably only need up to 225. So back to our problem. 36 is on our list, and that is the perfect square of 6. That just turns into 6. 144 also happens to be on our list, so that just simplifies to be 12. Now both of these are out of the radical, which means we can simplify them. I can divide top and bottom here by a common factor of 6, and that will leave us with our final answer of 1/2. So given the problem radical 3 over radical 12, that actually simplifies down to just be 1/2. All right, let's do another example. I'm going to switch colors here. So what if we were given something like 2 radical 5 divided by radical 50? So same thing, we need to get radicals out of the denominator. So when we're talking about radical division, we're talking about getting those radicals out of the denominator. So what we are going to do is multiply top and bottom by whatever radical is in the denominator. So in this case, that's radical 50. And remember, just like we talked about in our up here, that like multiplying by a radical over itself is equal to 1. So that's not changing the value, it's just changing the way that the problem looks. So this is going to be equal to 2 times 1 on the outside there gives us a 1. There is a 1 here, so 2 times 1 gives us 2. And 5 times 50 is going to be what's underneath the radical, gives us 250. On the bottom, we're doing 50 times 50, which is 2,500. So that is what we have on the bottom part there. Let me try to focus this a little bit better. All right, so now we need to do the simplifying step just like we did from here to here. So 250, it's not on our list, it is not a perfect square, but there is a perfect square that divides into 250. That perfect square is 25. 25 times 10. When we did 50 times 50, we got 2,500. That means that 50 makes 2,500 a perfect square. If we continue this list all the way up to 50 times 50, we would get 2,500. So that means that that simplifies to be 50. So remember, if you multiply any radical times exactly itself, it's going to make a perfect square underneath that radical, and it's going to turn into whatever that value was underneath your radicals there. But we are not done yet. We need to keep simplifying. So square root of 25 is 5. So this turns into 2 times 5, radical 10 over 50. And we can do 2 times 5 is 10, radical 10 divided by 50. And in our last step here, we did not have to do this in this problem because we did the simplifying, there was no radicals. This 10 is different than this 10 because it's underneath the radical. They are not the same, but we can simplify these two outside numbers by dividing them both by 10, getting rid of those zeros. So this answer comes out to be radical 10 over 5. So you may be thinking, how am I supposed to know when I get to my final answer? So things you're looking for in your final answer are, is the radical gone out of the denominator? Yes, we have that. And are all of your numbers simplified outside of the radical? So if you'd stopped at 10 and 50, that answer would be no. We'd have to do one more step to simplify. We divided 10 by 10 and got 1, and we divided 50 by 10 and got 5. All right, we're going to switch colors one more time and do one last example here. All right, in the last example, what I'm going to do is show you one other way that we can tackle some of these problems. So this is example 3. So if you were given something like -3 radical 8 divided by radical 40, we can simplify what's going on in the radical. So this is the same as -3 times a big radical of 8 divided by 40. That is the same thing as divide the top by 8, we get 1. Divide the bottom by 8, we get 5. And now we can put those kind of back in their respective places in the fraction. So that simplified our inside numbers, right? So we went back to this principle where if we had two separate radicals, we could combine them and make one big radical. I used that, and then I went back and I simplified them to two separate radicals. The square root of 1 is a perfect square, and that actually ends up just going away because that would give us -3 times 1 over radical 5. I'm going to have to move down here to continue our problem. So now we have -3 over radical 5. So we are not done yet because there is still a radical in our denominator. We are going to multiply top and bottom by whatever the radical is in the denominator. That would give us -3 radical 5 over radical 25. And that we know that the square root of 25 is equal to 5. So the last step to make sure that we finish this problem completely is if we have a -3 on the outside and a 5, do they have anything in common we can divide them by? No, they do not. And remember, we cannot combine what's underneath the radical by what's not. So this is in fact our final answer. One last example quickly if we're talking about variables. So let's switch colors one more time here. If we have something with variables underneath, we are going to have to deal with those in the same way that we were when we were doing simplifying. So what if we have square root of 49 over radical xy? So the first thing hopefully we notice is that 49 is one of our perfect squares. It's right up here, it's on our list, and that is 7 times 7. So the top of this really just turns into 7. And now we have 7 over radical xy. So let's get rid of that radical in the denominator. We're going to multiply top and bottom by radical xy, whatever is in our denominator here. So now on the top we have 7 radical xy over radical xy times radical xy would give us radical x squared y squared. But as we know, if I do radical 5 times radical 5, that ended up simplifying to 5. So by doing a radical xy times radical xy, that's going to simplify to just xy, which it would if I take the square root of x squared, that's x, the square root of y squared is just y. So now we have 7 radical xy divided by xy. There's a 7 on the outside and an xy. Those do not have anything in common, so therefore we are done. All right, remember that you can do your homework as many times as you like up until your quiz. When you are working on your homework, make sure that you're using these methods that we just talked about in this notes. Rewatch this notes as much as you want. You can pause at any time and let me know if you have any questions.